Hey everyone, and welcome to another deep dive with us.
Yeah, glad to be here.
Today we're going to be talking about neutrons.
Ooh, neutrons. Cool.
Yeah. I think they're really interesting. You know, they kind of get overshadowed by protons and electrons.
Yeah.
But they're key to so much.
Mm-hmm.
And we're going to be diving into this essay called, it's in German, it's called Neutronen, Schlüsselteilchen der Quantentechnologie.
Okay.
Written by Jargo Schneeppert. And basically the essay is all about how neutrons are not just, you know, what we learned in school is that atomic glue holding the nucleus together.
Right.
They're actually key players in this really exciting world of quantum technology.
Yeah, I'm really fascinated by that. You know how they're involved in, the basic structure of matter?
Yeah.
But also these really, really cutting edge technologies.
Yeah, absolutely. So do you remember learning about neutrons in school? I mean, I think we all kind of got that basic picture.
Yeah, just those little neutral particles hanging out in the nucleus.
Right, exactly, yeah.
Yeah. They're there to provide stability.
Yeah.
All those protons, they have the same charge, so they want to repel each other.
Yeah.
But the neutrons are there to kind of mediate that.
Right.
And keep everything from flying apart.
It's true, yeah.
So without neutrons, I mean, the periodic table would look totally different.
I know. It's crazy to think about, right?
Yeah.
But, this deep dive, we're going to uncover all the amazing things that neutrons do beyond just holding atoms together.
Definitely.
So the essay starts out, Schneeppert reminds us how important the discovery of the neutron was.
Right.
Like way back in 1932 by James Chadwick.
Yeah.
Which, I mean, earned him a Nobel Prize.
A huge deal.
Huge deal, yeah. But it turns out that neutrons aren't just, simple neutral particles.
Right. They're actually a little bit heavier than protons.
Okay.
And they're actually made up of even smaller particles called quarks.
Oh, right. Yeah.
You have 2 down quarks and 1 up quark.
Okay.
But all held together by the strong force.
It's like those words that you're like, oh, yeah, I remember those from physics, but
right.
Quarks, the strong force, it's like...
It's a whole other level.
Yeah, exactly. So, I mean, the point is that neutrons they're more complex.
Yeah, for sure.
Than we might think at first glance.
Yeah.
And as Schneeppert points out in this essay, they actually exhibit this pretty mind-bending property called wave-particle duality.
Yes. Think about those double slit experiments, where light acts like a wave?
Yeah.
But also like a particle?
Yeah. I remember learning about that.
Well, neutrons do the same thing. It's crazy. Yeah.
That's wild.
It's like this duality that makes them really useful for things like neutron interferometry.
Okay.
Where scientists can actually use that wave-like nature.
Okay.
To study materials on a really small scale at the atomic level.
So they have this, secret life as waves?
Yeah. Kinda.
That's amazing.
Yeah.
And Schneeppert goes into how scientists are actually exploring even more potential uses of neutrons, like using the spin of a neutron as a qubit.
Yes.
In quantum computers.
That's a wild idea.
I know.
So they have this intrinsic angular momentum called spin.
Okay.
And the essay suggests that you could actually use that to create this new kind of qubit.
I mean, that's still early stages, right?
Yeah, it's definitely early days.
But the potential's huge.
Oh, it's enormous. Yeah.
Imagine a quantum computer.
Yeah.
Built with neutrons.
It's crazy.
I know.
Yeah.
But Schneeppert actually lays out a pretty compelling case. And the essay doesn't stop there. It goes into a whole range of other applications for neutrons in quantum technology.
Yeah, it's pretty remarkable.
Yeah.
One of the things he talks about is neutron scattering.
Oh, yeah?
Which is this technique that allows scientists to study materials at the atomic level.
Okay.
Almost like using neutrons as these tiny microscopes.
Oh, wow.
Yeah, it's crazy.
Okay, so it's like they're able to probe the structure and the behavior of materials.
Exactly.
At that level.
Yeah.
Okay. That's really cool.
Yeah, it's pretty wild.
So welcome back to our deep dive into the world of neutrons. We were talking about all the amazing things they can do.
Yeah, they're so versatile.
It's amazing. And the last part, we were talking about how these tiny particles are so much more than just atomic glue.
Right. Yeah.
They can act as both particles and waves.
It's wild.
I know. It's like quantum mechanics in action. And that opens up all these possibilities, especially when we're talking about quantum technology.
Totally.
But also fundamental research.
Yeah.
Like trying to figure out how the universe works.
Yeah.
And as Schneeppert really highlights in his essay, one of the most amazing applications is in material science.
Yeah. It's incredible.
Like, they're these, like, tiny little tools to probe all these different materials.
Yeah, he really emphasizes that. How they can help us study the structure and the behavior of all kinds of materials.
Right, exactly. We were talking about neutron scattering earlier.
Yeah.
But I think it'd be great to, like, dig a little deeper into that.
Absolutely.
I mean, can you explain, like, how that technique works and why it's so important?
Sure. So basically, imagine you have this beam of neutrons.
Okay.
And you fire it at a sample of material that you want to study.
Okay.
The neutrons interact with the atoms in that material and scatter off.
Okay.
In different directions.
Okay.
And by analyzing the pattern of how they scatter,
right,
scientists can actually build up this really detailed picture of what's going on inside that material.
So it's like we're using neutrons as like tiny little X-rays.
It's a great analogy.
To kind of see like the inner workings of all these different materials.
Yeah.
Okay. So what kind of information can we get from this? Like, what can we actually learn?
So much. Like, Schneeppert points out that scientists are using it to study a huge range of materials.
Oh, wow. Okay.
From superconductors to magnets to biological molecules, even liquids. It's incredible. It can tell us about the arrangement of atoms, the distances between them, how much they're vibrating, and even magnetic properties.
Wow. Okay, so it's like a whole lot of information packed into those scattered neutrons.
It's amazing, right?
Okay.
And I can definitely see why Schneeppert calls this technique like a real game changer.
Yeah. It's not just understanding like what we already have.
Right.
It's like you can create new things.
Exactly.
Design new things.
It's helping scientists design and develop brand new materials with very specific properties.
Wow. Okay, that's really cool.
Yeah. So, it's driving all this innovation in energy storage, electronics, even medicine.
Wow. So those tiny particles are actually shaping like the future of technology. It's incredible. But Schneeppert also goes beyond these like practical applications.
Right.
He's talking about how neutrons are helping us figure out some of the like biggest mysteries in the universe.
Absolutely. One of the most fascinating things he talks about is dark matter.
Okay. Right. So dark matter it's like a huge part of the universe, right?
Right. A significant portion.
But we can't see it.
We can't see it directly.
It's invisible. So how do neutrons help us?
Well, the idea is that dark matter particles might interact with ordinary matter.
Okay.
Like really, really weakly.
Okay.
And that includes neutrons.
Yeah.
So scientists are trying to build these incredibly sensitive detectors to see if they can catch those interactions.
Oh,
it's like super challenging because these interactions are so rare.
Okay, so if like a dark matter particle happened to like collide with a neutron in one of these detectors, it would create like a signal.
Exactly.
That the scientists could
pick up. Yep. And often these experiments are underground, shielded to try to block out all the noise.
So you're trying to like...
It's like trying to hear a whisper in a hurricane.
Oh my gosh.
Exactly.
But if they were to like actually detect it, I mean, that's
a huge
deal.
It would completely change our understanding of the universe.
That's incredible. Okay, so we've got neutrons.
Yeah.
They're like little detectives, right? Helping us uncover these hidden secrets.
Yep.
That's really cool. But Schneeppert doesn't stop there.
Nope.
He also talks about how neutrons can help us understand the Big Bang.
Right.
The beginning of...
the universe as we know it.
Yeah, the universe. Wow.
Yeah. So the essay gets into how scientists are using neutrons to study the abundance of light elements.
Oh.
Like hydrogen and helium in the universe.
Right.
And these are thought to be relics of the Big Bang.
Okay. So it's like we're looking back in time to those like first few moments.
Yeah.
After the Big Bang.
Exactly.
Okay. So how do neutrons help us with that?
So neutrons were actually involved in those nuclear reactions that created those elements.
Okay.
Way back in the early universe.
Okay, so by understanding those reactions, you can like test our theories.
We can test our theories about the Big Bang, yeah.
Wow, that's incredible. Okay, so it's amazing how these tiny particles, we think of them as part of an atom.
Yeah.
But they give us these huge insights into the universe.
They really do. And Schneeppert also talks about another really fascinating application.
Yeah.
Using neutrons to explore the nature of gravity.
Oh, okay. Gravity. So how do they do that?
He mentions how scientists are using ultra-cold neutrons, which are neutrons that have been slowed way, way down.
Okay.
To test our understanding of gravity at, like, the quantum level.
Okay, quantum gravity. I'm getting, like, science fiction vibes here.
It might sound like science fiction, but it's a real thing that people are studying. The problem is our current theories of gravity, like Einstein's general relativity, it doesn't really work with quantum mechanics.
Right. They describe
totally different realms.
Totally different things.
So how do you bridge that gap? Well, because those ultra-cold neutrons, they're moving so slowly, their wave-like properties become much more obvious. And by studying how they behave in a gravitational field, scientists can potentially understand how gravity might work at the quantum level.
Wow. It's like these tiny particles that we think of as like just part of the nucleus of an atom. Could help us understand one of the fundamental forces of the universe.
It's crazy.
That's crazy.
It's a testament to how versatile they are as tools.
Wow. We've covered a lot in this part of the deep dive.
Yeah, we have.
We went from material science to the Big Bang to gravity. It's a lot. Schnephat's essay has given us a lot to think about.
It has, for sure.
All right, so welcome back to the deep dive. We're on the final part of our exploration of neutrons.
Hard to believe it, right?
Yeah, I know. It's gone so fast. We've seen how these tiny particles, they're not messing around. Really making waves, no pun intended.
Yeah, very versatile.
From changing the game in material science to, trying to unravel those secrets of dark matter and the Big Bang. It's incredible.
Schnephat really makes that point clear. In the essay, he really drives it home that neutrons are so much more than we give them credit for.
Yeah, absolutely. But before we wrap up, I'm kind of curious about, what are the challenges? What are the challenges that come with working with these things? I mean, they're electrically neutral, right?
Right.
So how do you even begin to, manipulate them, control them?
That's a great question, and Schnephat definitely acknowledges that working with neutrons isn't a walk in the park. There are some hurdles. And you're right, that neutrality makes it really difficult to manipulate them using, say, electric fields.
Okay, yeah, because that's how we usually mess with charged particles.
Exactly, like electrons.
So how do they do it? I mean, what are the tricks of the trade here?
Well, scientists have come up with some really clever techniques. One way is to use magnetic fields. Because neutrons, even though they have no net charge, they do have this thing called a magnetic moment.
Right.
So they can be influenced by magnetic fields. And they also use things like diffraction, reflection, bouncing them off surfaces to kind of guide them.
Okay, so it's like a whole...
It's complicated.
It's complicated, yeah, I can imagine.
Yeah, it's a lot of very precise manipulation.
Wow. And I guess another challenge that you face is, well, how do you even get your hands on... a bunch of neutrons to work with?
That's another good point, and Schnephat talks about this too. Access to high-energy neutron sources is limited.
Right.
These are typically large facilities, like nuclear reactors or spallation sources, which are basically particle accelerators that are designed to produce intense beams of neutrons.
So it's not something you can just, set up in your basement lab?
No, definitely not a DIY project.
Right.
It takes a lot of resources, a lot of expertise to operate these facilities.
I can imagine.
And, there are also safety concerns, especially when you're dealing with neutrons from nuclear reactors.
Right, yeah.
Schnephat emphasizes, you have to be really careful with shielding and handling.
Of course, yeah.
Yeah.
Safety first.
Absolutely.
So despite all this incredible potential, we've got these hurdles, these challenges, but what about the future?
That's the exciting part. Schnephat actually ends the essay on a very optimistic note.
Okay.
He talks about some really cool developments that could make neutron science a lot more accessible.
Oh, okay, great.
For example, people are working on miniaturized neutron generators.
Okay, so smaller.
Yeah, smaller, more portable.
So you could have one in a lab.
Exactly. Maybe even industrial settings one day.
Wow. That would be amazing. It would really open things up.
Oh, yeah. The possibilities are endless. And Schnephat also points out this really interesting trend of neutron science merging with these other really cool fields like quantum computing and AI.
Wow. So working together.
Yeah. Imagine those fields all working together to really push the boundaries.
That's an exciting vision of the future.
It really is.
Well, I think it's safe to say we've all gotten a whole new appreciation for neutrons.
Absolutely.
They're not just, sticking to the nucleus anymore. They're these incredible tools for, understanding the universe.
Kind of rescale.
Yeah. From the tiniest particles to the, vast expanse of the cosmos. It's incredible.
Yeah, and I think Jürgen Schnephat's essay, Neutronen, Schlüsselteilchen der Quantentechnologie, has given us a really fascinating look into, the world of these amazing particles and their potential to shape the future, not just of science, but also of technology.
Absolutely. Well, thank you so much for joining us on this deep dive, everyone. We hope you learned something new and exciting. And as always, keep those brains buzzing and stay curious.